Go.
Hey Ty,
Yeah, Alan.
have you ever heard that an egg won't break if you push on it equally from both sides?
Wow, really? Did you know that, Mr. Kibbles?
I don't think he did.
Huh. Weird.
Well, that's actually a lie.
Ah! Cat's gone.
You have to
that
push on
all
it
over your
from the
chest.
right sides.
You have that all over your chest and on me, and I have to go do stuff later. Dang it.
Alright, so now that we've cleverly determined that an egg cannot, in fact, take pressure from both sides when it is sideways, we need to determine whether or not it can take it when you push on it equally from the top and the bottom. As you can see, I'm pushing as hard as I can, and it just won't break. But there are things stronger than my fingers that we can test.
The reason we can't push down on the egg is because the force in the normal direction plus the force weight of the egg will overcome the force of the finger pushing down. Right, Alan?
Yeah. Now, to test the myth, we need to make sure that the forces are equal on both sides. And as Joel explained, we can't push down on it. So, by pushing on the side, the force my finger applies on this side should be equal to the normal force being pushed against it by this wall. According to the myth, the egg won't break, no matter how hard I push. So let's see if that's true. This poor egg did not survive. At the unfortunate demise of the egg down there, it is clear that pushing the egg against the wall does not demonstrate the myth correctly. Now, it might be that by putting my finger on one side of the egg and the other finger at the other, and pushing, the forces are more equally distributed by the force being distributed throughout that area and not on a single point where the wall is touching. So, to do a better test, we can have my finger push on one side and have Ty's on the other.
Round 3. Ty versus Allan. Begin.
Wait. No. Oh god, this isn't good. Oh my word!
Oh, wait, just stop. Just stop. Oh. Look at that finger. Ow. Ow. Oh my god. Well, that worked better, actually.
Alright, now let's try with our palms. This time I'll take the point.
Okay. Alright, palms.
Ty versus Allan. Round 4. Begin.
Oh god.
No, it's not even. Stop. Make sure it's in the center. Alright. Wait.
Wait, it's not it's not saying correct. Here, maybe like that?
No.
No, wait,
Sorry.
make it sideways.
Stop. It's not working. What the?
The egg is unbroken. An explanation for why the egg doesn't break can probably be construed through the fact that it is more round in its shape than spherical. Well, cylinders are one of the sturdiest objects for when you apply weight straight down, and the reasoning for this is that because of their circular shape, there is no clear point where it is weakest. So the weight can't, or the force can't break out from one side when you push down. It's round. That's why trees have a cylindrical shape when they grow. It's so much more sturdy. And just like that, the egg is round in its shape. So when you have the force distributed across the circumference of the egg, there's no one spot along the eggshell where it is weakest in a perfect egg shape. Now, we didn't necessarily prove the myth because, for all we know, at an extremely high force, more than what Ty or I can possibly push, the eggshell may still break. So what we can say is that this myth is plausible.